Assalamu alaikum. Today we are going to present the paper An Image Processing Technique for Coffee Black Beans Identification. My name is Tarique Hassan and my group member is Mr. Suhail Ahmed. A bit about the paper. This paper was published in the conference in Bangkok, Thailand. The conference name is IEEE International Conference on Innovative Research and Development that was held on 11th and 12th May 2018. The country from which the authors belong is Philippines, and the publication year of this conference paper is 2018. And these are the authors: Edwin R. Arboleda from Philippines, NLC Fajardo from Philippines, and Ruji P. Medina from Philippines. And all these three authors have graduated from the same institute, Technological Institute of the Philippines, Quezon City, Philippines. And this is the title of the paper, An Image Processing Technique for Coffee Black Beans Identification. Abstract. The quality of a coffee bean is determined by several factors, including color, texture, and size. High quality beans are carefully refined, where defects such as black beans are removed. The problem with the previous applied technique is the assessment through which visual inspection was subjected to be external, such as light and the amount of beans to be inspected. And the proposed technique in this paper presents a method of controlling the coffee bean quality using image processing techniques, in which normal beans are identified through the extraction of RGB components of training image, and the RGB values are integrated in an image processing technique that eliminated the black beans in the image. And 100% accuracy was obtained in classifying and eliminating the black beans in an image using the proposed technique. Coffee, as we all know, is one of the world's most important and most widely consumed beverages. The coffee drink undergoes a careful process in order to achieve a great quality. There are several factors that affect the quality, like the process on how the coffee is grown and harvested, and how the fields are processed. Deficiencies in nutrients and the use of inadequate protection against coffee diseases will lead to lower quality coffees. And another factor that comes greatly into consideration is the ripeness of a coffee cherry. It is important that only fully ripened fruits are picked. Picking of unripe or overripe fruits greatly affects the quality of coffee. So, to avoid these bad factors, good harvesting methods are important to produce good quality coffee. The two crucial steps to ultimate quality and character of the coffee are drying the seeds and then removing the fruity parts of the seeds. This is actually background of the problem that we will propose the solution to. Knowing that some of these precious coffee beans are defective lessen its quality. One of these defects is called black beans. What are black beans actually? We can consider black beans to unroasted coffee beans with more than 25% black, deep blue, or dark brown surface area. And these black beans come from uh, harvesting immature cherries or by harvesting dead cherries that fall naturally from the tree. Or black beans can also result from exposure to water, heat, and insect damage. And what is the need for the proposed technique? Actually, the conventional process of identifying coffee defects such as a black beans is by general inspection and just by looking using the naked eye. That consumes a huge amount of time and also has low accuracy because it is subjective and depends on the condition of the person doing the task of separation of black beans from normal beans, which actually consumes huge amount of time and has low accuracy as well. And we will solve this problem using the MATLAB. The authors see the need of automated image processing technique for this kind of process by using the color features of the coffee beans using an algorithm in MATLAB. MATLAB is one of the easiest and most productive software, we all know that, in which image processing can be done. And in using image processing, objects can be determined and classified. Several diseases can be spotted and many other applications. These have already been used in many fields such as remote sensing, medical science, air traffic control system, radar system, and forensic science, and several others. The methodology that was used by the authors to publish this paper. Robusta coffee is from the coffee canifera plant, which is a sturdy species. Its coffee beans have a low acidity and high bitterness. National Coffee Research Development and Extension Center has produced these coffee beans used in this study were the collection from this center, which is from Cambridge State University, Indian Cambridge. And the snapshots of the Robusta coffee bean samples were taken by placing the samples on a white background using the device Sony DCS 820.1 megapixels camera digital camera is shown in the picture. You can see this picture. This was taken using this device. And image this image was processed using the laptop with these specifications. We can see Intel Core i7 6700 up to 3.5 gigahertz and 4 GB RAM and plus 1 TB hard disk and Microsoft Windows 10 Professional 64-bit operating system using the trial version of MATLAB or 2018A platform. And the color feature extraction that is used in the MATLAB in the implementation of this paper. This color feature is the most widely used visual features in an image retrieving and indexing. The most important advantages of this color feature extraction are the power of representing visual content of images, simplicity in extracting color information, a high efficiency in separating images from each other, relatively robust to background complication, and independent of image size and orientation. A color image is, we all know this is basic definition of color, is a color image is a combination of some basic colors and the MATLAB breaks each individual pixel of a color image termed as true color down into red, green, and blue values. The authors gathered these RGB values by using mpixel function that is used to display the RGB values of selected pixel. These values that were gathered in RGB extraction were tabulated using the Microsoft Excel, which will be shown in the next slides. And further, Mr. Suhail Ahmed will continue. Thank you.
In the training and testing process of methodology, a total of 180 Robusta coffee beans were used in this study. The 180 coffee beans were grouped in two major groups, the training group and the testing group. There are 70 normal beans and 50 black beans used for training, and for testing 35 normal beans and 25 black beans were used for testing. The training group was used to get RGB value range of both the normal beans and the black beans. The training process was done to extract the values of parameters that will be used in the testing process. Using MATLAB software, the images containing the normal coffee beans was loaded on the software by using command imread. The flowchart of the training of the proposed technique in this paper is shown in figure. In the figure, a flowchart, first we are loading images of normal and non-defective coffee beans. coffee beans and the black beans. After that, extract and determine the range of RGB value of normal coffee beans and the black beans. Next, eliminate the RGB values of the image that are out of range of normal coffee beans and fill out the holes of the images that was left and determine the minimum area value that would be produced by normal coffee beans and eliminate all images that are less than the minimum area of normal coffee beans. In last, show all white images indicated the position of normal beans that was left. And values were extracted from the image by command impixel as shown in a figure. It is proposed its purpose is to obtain RGB value of point picked by the user. The author picked the center point of every beans in the training image. The value for the color red, green, and blue were obtained. The same procedure was repeated for the images containing all black beans. Table 1 shows the RGB component value for the normal beans and table 2 shows the RGB component value for the black beans. Comparing the RGB values in table 1 and table 2, it can be seen that normal beans has higher RGB value than its black beans. Counterpart of all components red, green and blue. In the table 1, red has range 143 to 181 and green has values 103 to 155 and blue has 67 to 104. In the table of the black beans, the colors are red has a range 37 to 108 and green has 28 to 87 and blue has 19 to 70. After the RGB variables for colors were established as shown in a table and table 2. The commands such as these were used red, green and blue. And the output variable is the output that contains the extracted ranges of red, green and blue by comparison. The output image from this command is an image showing the beans with RGB value that is within the range stated in the command. Some of the beans will have holes that are needed to be filled. This can be done by using infill method. The area of filled holes were also trained by determining the minimum value of area of filled holes that will be classified as a normal bean. The minimum value of filled holes area was used as a filter by eliminating objects that are less than its value. The values extracted in the training process were integrated in the testing process. The RGB values of normal beans served as the upper and lower limit, where in values that are out of the range were eliminated. The minimum value of filled holes area in the training process was also integrated in the testing algorithm. Figure show the flowchart for the testing of the proposed technique. In the flowchart, load images containing both the normal non-defective coffee beans and the black beans in the same image. After that, eliminate the RGB values of the image that are out of range of normal coffee beans. Fill out the holes of the image that was left and eliminate all images that are less than the minimum area of normal coffee beans. And last, show all white images indicating the position of normal beans that was left. The purpose of this paper is to make a series of codes that will discriminate normal coffee beans from black beans. The elimination of coffee, black beans, and pointing the position of normal beans was implemented using the MATLAB software. The strength of this technique is the training process wherein the RGB values and minimum area of filled holes of normal beans were extracted. This technique was trained using 70 normal beans and 50 black beans and tested using the test sample of 35 normal beans and 25 black beans. This figure is the original image where the proposed techniques was tested. The range of values of red, green, and blue were integrated in the MATLAB code. The RGB values not within that range were eliminated by the program. The images left was enhanced by filling the holes. After the holes were filled, the area of all objects left were determined, and those areas that are below the predetermined area value derived from the training process were eliminated. The white marks left are the position of the normal coffee beans. It can be seen in the original image that the normal beans and black beans are together in one picture. After the picture had been processed using the proposed image processing technique, it can be seen that the black beans in the original image have been eliminated. The output of proposed MATLAB code is shown in a figure. The white image is in a figure shows the position of the normal beans in the original image, and this method has 100% accuracy and classifying and eliminating the black beans in an image using the proposed technique. In the conclusion, the process done by the author to determine and discriminating the coffee black beans has been successful. The color ranges were used to determine the normal coffee beans and the black beans. The discrimination was done by extracting the beans with a low area value than a regular one. The coffee bean with the black bean defect in its skin has a very negligible output area, thus they are eliminated in the output range, leaving only white marks that indicate the position of the normal coffee beans. The proposed image processing technique could also be applicable not only in discriminating the black bean defects of the coffee, but could also be used on other quality defect related to color. Because the proposed technique was trained and tested only in a total of 180 sample, it suggested that the proposed technique be trained and tested using larger number of samples. That's all about this paper. Thank you.